All right, so your 3 kilogram turkey leg slides off your plate, incline at 60 degrees. Find the acceleration of the leg if the plate has a coefficient of friction of 0.12. All right, so first things first, we are going to change 0.12 to 0.1 to make our lives easier. So this incline represents your plate. This little square represents the turkey leg. Now we know that the weight points straight down. We know that the normal force is perpendicular to the surface. And we know because there's a coefficient of friction that there's going to be some sort of frictional force. Now, we also know that there is a parallel component of the weight, and there should be a perpendicular component of the weight. Now, in order to solve for acceleration, we're going to use the equation F net is equal to m times a. Now, if we look at the direction that the object's accelerating, the only forces we have are F parallel and friction. So that's going to be equal to m times a. And to solve for a, obviously, all we have to do is divide by m. So a is equal to the force parallel minus the friction divided by m. Now, I know the equation for the parallel component. I do not know friction, though. However, I know that friction is really just equal to mu times the normal force. And I know that the normal force is really just equal to Fg perpendicular. So the force of friction is really just equal to mu times mg cosine theta. All right, so if we go back to our original equation here, F parallel, we know that's mg sine of theta minus friction, which we know is mu times mg cosine theta, and then all of that, gets divided by m. So now it's really just a matter of plugging stuff in. So it's going to be 3 times 10 times the sine of 60 minus mu, which here is 0.1, times m, which is 3, times g, which is 10, times the cosine of 60. And all of that will get divided by 3. So you end up with an acceleration in and around 7.66 meters per second squared.